Okay, thank you, thank you.
That's for your slide.
That's for my slides. Okay, great. Yeah, I'm actually speechless because what I wanted to do is to talk with you about where the humanities and social sciences are positioned in the development of quantum technologies. And actually, the short answer is go to Grenoble because there you can see what the role is. So, in a sense, what I will be telling is something you probably already know. Maybe I'm only making it explicit. But I feel at home. Yeah, one word about why it was so much trouble. To get here. I was in Helsinki. Yesterday I woke up in Helsinki. I'll tell a little bit about that. And then I managed to to sit in two planes which broke down at the moment that they would go away. So only the third plane brought me to Paris. And Pierre and Amélie, we were like crazy trying to get me in one piece here. Well, I am in one piece here, but please note two things. One, don't come near because something will break down if you do. And second, if I wander off, please warn me because I'm somewhat jet lagged, although there's just 1 hour difference between Helsinki. Anyway, yeah, so it really is. Congratulations to Thierry and Amélie about this this program which you run. And TIQuA is now coming to an end, but it was a great program. I looked, of course, before we went, before I made my slides. Okay, to whom am I talking? And I was simply impressed. And also framing the whole alt quantum vision as something which runs from philosophy to industry, yeah, that is dear to my heart because it says something that philosophy is simply, or I take that as humanities and social sciences is just part and parcel of quantum technologies as being developed. And well, the TIQuA program contains all these elements, and I think, yeah, great, that should be done. We should do more of it, and it's difficult to do that. I'll present a bit about my own. Well, no, the other way around. See, that's the jet lag. Yeah, here. So what I will do is say something you already know. Where are the humanities positioned in the development of quantum technologies? I was asked to say a little bit about myself, what kind of research I'm doing in my own university as part of the Dutch program on developing quantum technologies. I realized when doing that, I'll do it anyway. I realized I don't like it. I don't like talking about myself. So I'm much more focused here on the future and seeing what we could do in the with the social sciences, humanities, in the development of quantum technologies, and then hopefully also have time for discussion with you. Okay. So, quantum technologies and its development. In order to position ourselves in that domain, I present often three elements which are part and parcel of quantum technologies. One is really developing fast as a regular technology. Quantum technologies are not special, they're just technologies. But what is special is that it goes quite fast. 20 years ago, it was just science, and now all of a sudden it's technology. At this time, everyone is talking, working on how to bring these technologies to industry. We talk about startups, scale-ups, and thirdly, everyone is talking about how to get use cases which can embed quantum technologies in society. So it goes quite rapid, and there are also so many people working on, so many institutes, so many countries. Second, there's a feeling that it's not a right feeling, but it is a feeling we should do it right this time. And that suggests, and that's a feeling which is around, that we didn't do it right previous times. And politicians, managers think then about AI, ChatGPT as an example, say, wow, that hit society. We were not warned about that. All of a sudden at universities we have to deal with students and teachers who write with ChatGPT. Suggesting that indeed we should have informed them. They were informed, of course, but nevertheless that feeling is there. For the next technology, and that's us, quantum technologies, we should anticipate immediately what kind of applications come, how it will change society, and we immediately should start steering these applications in a meaningful way. Which is quite fast because most of these applications don't exist yet. But we already have a license to start intervening on that. We should get it right now. Moreover, this is kind of more responsive. The technology develops, applications come, and we steer. There's a second threat, which is we should not only just develop technology because it's possible, because we can earn lots of money with it. No, we should immediately design it for the benefit of humankind. It was the World Economic Forum and other organizations which took up that, which said, yeah, let's use this time quantum, the new emerging kid on the block, for humanity, not just for making money. That's also specific of quantum technologies. Thirdly, if you look at the goal, it is a moving target. 10 years ago, it was about Quantum Valley. The idea was we lost in Europe Silicon Valley. The Americans had that. This time, this technology, we are going to nail it. In Germany, I think there are multiple regions called Quantum Valley. So even before it exists, they already claimed the spot. That time is, in a sense, over. Since a couple of years, we talk about sovereignty. That's the goal of quantum technology. We do it here to remain autonomous as states, and to have our own say. And I think, if I'm right, defense is pretty soon a third goal on the horizon. So it's a moving target. So we can't just say it's for this and let's analyze it. Well, let's go to the humanities, and in order to position the humanities, let's position first our competitors. Physics. Is it all physics? And if you look at, I don't know about Grenoble, but if you look at my university, TU Delft, or if you look at the European flagship, it's physics. So, yeah, is it driven by physics? Yes, of course. Quantum technologies, science became a technology. Those were the physicists doing that. But then, actually, the rest also. The startups, the scale-ups, they were founded by the physicists. Okay, let's do that too. And if you look at the European quantum flagship, you see that also there it's dominated by physicists. That's the leadership. They, of course, bring in new knowledge. They're smart enough to do that. But they also say, yeah, well, we're going to embed it into our societies. Of course, they think about the technical infrastructure. We can embed quantum internet into the normal internet, but also, yeah, the way in which it disrupts our society. That's in the realm of physics. What's happened? What's left for us then? The social sciences. Well, yeah, we're about society. Sure, we know what good is. That's what these physicists don't know. They have their formulas. They don't know about ethics. They don't know about other societal issues. Well, I would say this is dead wrong. And I think, in a sense, the TIQuA gives a good example. This is not the case. We are all over the place. If you look at how a technology goes to industrialization, innovation in general, well, Thierry is you're the expert. It's not physics, it's management. Your society comes in, you analyze markets. Lots of actors are there. So it's for sure also a humanities part. And we are the ones who should steer, give feedback to the physicists about how to steer these technologies. It's not just to them. We should collaborate. I'll come back later to this picture or to this mindset. I had to think about why do we accept the physicists to be such dominant? It's not only the physicists who think that they rule the world. We all think that physicists have a kind of special case. And if you think about history in the 20th century, yeah, physicists, they did lots of theory, but if something went wrong in society, they stepped up and wrote a couple of letters, say you have to change this and that. So the Second World War and the disaster with the Challenger, and the physicists step on the podium and say, check this out, do it better next time. And we like that view, and it's part and parcel, I think, of quantum technology and its development. But we should not accept it. I think we have something to say too. Okay, let me now go to myself and say something about the Netherlands and the way in which quantum technologies are developed there. And you can see that this mindset, that it's a physicist endeavor, is also entrenched in the program which the Netherlands has developed for developing quantum technologies. It's called Quantum Delta NL. It's 7 years running, 600 million, so it's massive. We're now midway, and it was organized like this, like that onion model. The triangles are hardware, clean rooms, test beds, but the activities, those are the blue circles. In the middle is research. Lots of money goes to that. And it's physics, physics research. And then the rest is shells around it. So that's how it is organized. First shell is that industrialization, startups, and we also have a venture capitalist. That's really great with our house venture capitalist. But he is in shell, the first shell, action line 2, and then the next shell around the physicist is talent development, education, attracting the bright minds to the Netherlands in order to get it going. We, ELSA, ethics, legal, social, and what we do, that's the last shell around the whole thing. It's just a model, but what it presents is that we are kind of the interface with society. Quantum technologies are developed by the physicists. ELSA, human sciences, are around it to present it to the outside world, and we do, and also to get up some feedback in order to correct some of the core business. Well, what is this outer shell organized of, consisting of? So this is just the ELSA effort. It's also massive. It's lots of people working on it for 7 years. It's wonderful. It consists in part from a center, an institute, which is called Society and Quantum. And what that does is to reach out to whomever is interested in order to explore with stakeholders what quantum could be. It's not design, but it's more workshops. There's a little methodology for that developed exploratory quantum technology assessment. And whenever an industry or a governmental institute wants to know what quantum means for them, what may change their activities, we run workshops in order to find that out. More actively, what we do is Quantum for Good, that more on humanities oriented aim of quantum technologies. We run projects how you can use quantum for the benefit of for addressing some societal issue. We just had a contest on how you could use quantum sensing for microplastic recapture from the oceans. And that's a challenge. Students could come up with plans. And we do that with students, but also with the more international UN institutes. Finally, we interact with international policy, and then in this case, not G7, but UNESCO and OECD, and work with them in order to help them shape the international technology with respect to quantum technologies. I'll come back to that. Then there are 3 research groups in it. ELSA is Ethics, Legal, Social. So I'm the Ethics, I'm E from Ethics. Then we have L, that's Joris van Hoboken in Amsterdam. He has a group of about 7 to 10 people working on legal issues of quantum technologies. And then the S is communication science. How do people communicate about quantum technologies, and how could they communicate about that? That's Julia Kramer in Leiden. To give a couple of examples from my own group, so I'm at TU Delft, and this is my team. Overall is, of course, our assignment is to develop the ethics of quantum technologies, and also clarifying what quantum for good may mean. More specific things which I highlight. Well, what I did with in Helsinki was with my postdoc Ben Lane, working with physicists in a project aimed at just building a quantum computer with 100 qubits. So there were lots of people thinking about that. We were there as ethicists and raising the question, okay, what happens if you manage to do that? Who can use your computer? So you have this, you make quantum computing time available. How are you going to define that? Is it science? Is it industry? And so on. So those kinds of questions we pick up, and it was quite nice to see that they actually wanted to use it for basic sciences. Let's use quantum computing for that, whereas it probably will be used for other means. Then I have a couple of PhD projects. We're going to talk later about RI. So what I highlight is, well, one actually which resonates with work which has been done here on the ontology of quantum mechanics. I think it's here. Thijs Latte is is working on the ontology of quantum technologies. How do engineers working in quantum technology are going to understand the reality of quantum mechanics, of the quantum world? The physicists typically shy away from saying anything about the quantum world. They say, no, it's not about that. We do measurements, we can say something about that. We don't talk about what is in between the measurements. The assumption under this project is that for engineers that might be different. If a whole group of large contingents of students come in who have to learn about quantum technology, well, they will use all kinds of pictures, and we're trying to understand that in order to improve education, for instance. Another one is values in quantum internet. Quantum internet is a technology built to realize secure communication. Because it allows QKD, quantum key distribution, and that allows securing your communication, your digital communication. The question is, what other values are part and parcel of the designs of quantum internet? There are different designs being developed. In China, you have a big quantum internet. America is working on it, Korea, also Europe. What kind of values are embedded in those designs? What can you say about it? How can you change it in order that you have a quantum internet which supports those values? Those are the kinds of projects I'm working on. If you want to know more, I'm around today, tomorrow, so happy to say more about that. Let's go back to the bigger picture. So this was the onion model by which it was the Dutch program was shaped, and where the outer hull, suggesting that we don't interact so much with the internal hull. Well, the experience in the last 3 years is that we do. We constantly talk about with all the actors in the quantum ecosystem. The legal people speak with the researchers about standards. We ethicists talk with the leadership of Quantum Delta NL in order to think what our position in international policy would be. So we're not the interface with society. And drawing from the triple helix model of innovation, that you have 3 strands, which interact with each other. The 3 strands are research, industry, and governments. There they are. What I see is that we, from the social sciences, are interacting with all of them. We are like a cable, so this is the cable model, like a cable, kind of enveloping them fully, and kind of a catalyzer. I don't know, I don't have yet the terms right, but we are enveloping them, interacting with all, and also helping them to realize their goals. It's not that we analyze from the outside, say, oh, they are doing this, they are doing that. No, we interact with them, helping them to get the job done. Well, this model I would like to use, and the characteristics of quantum technology development, to see what promises and challenges are. First observation which you can make is that it's the moving target feature, is that it's not anymore 3 strands which interact. There are a couple of new strands entering the game too. International policy is itself already a player, a stakeholder in the development of quantum technologies. UNESCO, G7 I just heard, are part of the development of quantum technologies. So they're also in the cable. And probably defense is soon also one of the actors within the cable. Well, that means that lots of new research becomes available, and to some extent you have already done it or already picked it up. And so interaction with governance, so taking up issues on how to govern internationally quantum technologies. Yeah, that's. We wouldn't think about that if you talk about biotechnology. Yeah? Ethicists, legal people would say, "Oh no, okay, let's talk about a couple of applications." Now here we talk about the whole thing, so there is the invitation, a new promise, a new topic on the horizon. Let's help with the governance, and then also dilemmas come to the surface, which are present there. And so the European Union wants to have quantum technologies primarily for itself, because it's for our sovereignty. And yeah, we also had a couple of years ago something like international solidarity. If you look into the legal speaking into their manifests, that's what's center. It's about avoiding conflict. It's about understanding each other. And all of a sudden, we just shut down all the borders and do that easily. Well, these are the things which we should pick up, and they're not on the outer shell of the development. They're right in the middle. Others are, well, we'll talk about that probably in the panel. RI in geopolitics, how can you think about stakeholder consultation if we're not allowed to talk with other countries? I'm not allowed to go to China, I can tell you. Things like open strategic autonomy, yeah, it is a concept which is around. I actually don't know what it means. And it's quite a moving target in itself. So there we can do new kinds of work. And yeah, to some embarrassment, but I think it's fair to say, military ethics, which in my field was, yeah, a fringe topic, something of the past, it's coming right back. And we should take it up, unfortunately, quite fast in order to also be prepared to have something decent to say about it. Yeah, the do it right element is also it's a prospect. It's a promise. We can make a difference much more as compared to ethics of other technologies. We can give content to that notion of quantum for good. We can support the other actors in driving the development towards the good and help the new actors also. How am I doing with time, actually? 5 minutes, great. So those are the prospects I see, and I'll come back to that in a minute. They also require that we change a little bit in our way we do our work. But what I realize is that it also, if we take up these prospects, it also requires that our context is different, that we are enabled to give these contributions. And that's a project I'm engaged in, especially in the European Union, where it's really, the development is dominated by physicists who fly in other expertise. If you tell them, well, look, we can help you with developing your policies, we can help you resolving your issues, then typically they say no. And that would be then the end of our promises, of our prospects. In order to undercut that, we started Europe-wide an effort to ask or announce to the European Union that we are here and we can help, we can support. We are not the critical people outside, we are the supporting people who can help addressing issues. So this is kind of a manifesto style text, which you can find if you click on that QR code. And there's a call for the European Commission to, in their new plans, give more room for us, not so much money-wise, but to incorporate the interaction with our fields. And you can support this call. You can sign it, you can add your own research to it. You can add a slide saying, hey, this is what I do. So if you need support, come to me because this is what I can. And that is work which I've done with a couple of people, including, I'm really happy, and I now immediately see also, this is a center which has the expertise with Amelie. So great. This is a call for our context to change, and we hope that you can support it and that we can realize that change. We should change ourselves also, I think, and that is that we should get out of our comfort zones of academic research. I like it a lot, this field, because it changes my work completely. I am in that rhythm of 4 years PhD students, 2 years for a paper. The review process was fast, it's just half a year. And it doesn't make sense in quantum technologies. The goal, that moving target, it's outdated if it's published, more or less. So we should become faster and also offer indeed our knowledge as a package which can be used. So we should bring together our knowledge, our approaches and skills, and hand it over, make it available to these other actors, and become a group which can realize jobs. And I emphasize that because if I reflect on my own field, it's sometimes also a field which is kind of reluctant to make progress. If we have a method, we start criticizing it. Say, no, I'm not sure if we really can do this. And so before it is boxed, shipped out, it's already criticized and we cannot sell it anymore. I think it's good that our field is self-critical, has that ability, but I think we should also get over it to really offer ourselves as in support of the other actors in this development. And that also means doing other types of work, engage with broader audiences. So also ethicists do already consultancy, but why should we not be on the board of quantum organizations and take the executive role, including all the responsibility which comes with it? We won't get our say always. We're just one vote in the board if you would do something. I think we should go in that direction. It's not easy. What I realized was white papers is the fast mode of publication. We got preprints also. That's the in-between. Physicists have preprints. Philosophers don't have preprints. Okay, you could do that. White papers is much more faster. You analyze the topic, you come with a couple of recommendations, you ask Pierre to give it a nice layout, you ship it, and you're done. And that's a matter of a couple of months. The downside about that is what is actually a good white paper? What is, from an ethical, legal point of view, a good white paper? We don't have that knowledge. So we should be careful not to just generate white papers, but think about, okay, how do we do that in a meaningful way. So these are the challenges which come with this new role which we can take. Okay, last slide. Conclusions. I told you something which you already knew, what's the position of the social sciences, humanities, philosophy, ELSA in the development of quantum technologies. You already took that position. But then I developed a bit more and say that we should also be proud, get rid of that idea of Einstein, Bohr, and Feynman, that the physicists are dominant, and come up with a model of how we can interact with the actors in the development. My take-home message is we are everywhere. We are invited by the community to help them make quantum good. That is there, and I think we're in a position to accept.
Thank you.